there's day one of 1.1 and 1.2. So there's going to be some general basic just starter info on the unit. Nothing too crazy here, things you've definitely seen before. So if there's at a point where you're like, oh, I already get that, you can kind of skim through to what you need to know for the notes. So let's see. To fill in the blanks here, it's a function is a mathematical relation that maps a set of input values to a set of output values such that each input is mapped to exactly one output value, right? That's what it means to be a function. We tend to use the vertical line test for this when to determine this pretty quickly, whether or not this pencil or an invisible vertical line that you imagine only crosses our graph just once, right? That's what it really means that is mapped to exactly one output value. Now, to cover the rest of the spaces that we have here, the set of input values of a function is called the domain, right? The list of all input values is a domain, usually represented by the x variable. And the set of output values of a function is that's called the range, right? Hopefully we remember those key terms, and this is represented by the y variable. Okay. And the next few examples here, they're asking us to sketch a graph given the domain of -4 to +4, right? And I'm going to emphasize this, right? This domain is using the x variable, and these inequality symbols are using the or equals symbol. So we might elaborate more on that once an example comes up uh, that concerns those specific things. So let's see. This first one's asking us to sketch. So the function f halves each input and adds 1. So right now we're starting off with a domain restriction, right, based on this right here. But then now the statement that they give us in question one is, well, we really need to write a function that represents that, right? So it says that we have a function f that halves each input value. Remember that an input value is represented by the x variable, right? And halves probably just means 1/2. And then it adds 1. So we can write this function relatively easily, right? So most functions start off as with a name. Let's say the function f with subject x or f of x. Um, this is equals to, well, 1/2 halves of each input, right? That's what that means. You're taking 1/2, you're halving each input, and you notice that's multiplying to x, or input value. In the last statement, we just make sure that we add 1 to the whole result, and we have written a function that matches what they describe, right? Something that halves the input and then adds 1 to it. All right, so now we'll just take a moment to graph it. Shouldn't take too long. If you want to skip to where I actually do finish graphing it already, feel free to do so. I'm just going to take a second to graph it in case you want to follow through it with me. All right, so um, it seems like I have a y-intercept of 1, so that means I should have a point there to start off with. And then I know based on the coefficient, the number in front of the variable, 1/2, this indicates the slope of the function. So I know that I'm going to rise and then run, or sorry, rise 1 and then run 2. So from the y-intercept that I've already graphed, I'm going to go ahead and rise 1 and then run 2 to the right, and this will correlate to the next point that I'm going to draw. Pretty simple stuff. Hopefully you remember that, and I'm just going to start graphing the rest pretty fast now. Oop, that's really wrong. It should be run 2, down 1. There we go. And then I'll just connect it with a line to finish my drawing. And I know it's a little bit off right here, but you get the idea. All right, let's move on to number 2. Now we're given a formatting of a table to represent this function named g, or g of x, right? So we're just going to take some time and just graph the points and connect the dots if we can, if they seem like it's a continuous function. If not, we'll leave the points as is, because really um, this function is not exactly described to be connected quite yet, but we'll graph it anyways. So I have -4, -1, so there should be a point there. -1, 2, 0, 3, 2 comma 3, and then 4 comma 1. Right, so um, those are the points represented by each of these coordinates represented here for the list of domain and range values. And so I guess I can connect them since it's supposed to be describing a function, right? And so if I connect all of them, oops, this is what, oops, this is what it should look like. And there we have it. We have a graph that represents the points that they told us. All right, there's problems 1 and 2. I'll pause here in case you want to pause the video just to double check your work. And then let's move on to the main idea that we're talking about, right? Which is average rate of change. I think I should have talked about the name, right? Change in tandem, right? That's pretty much average rate of change. So let's take a look of what we fill in the blanks here. You've probably seen this equation, or sorry, formula at some point. It's basically just like the slope formula, right? Average rate of change just also means slope. So whenever you see this, just also think slope, right? So to find the average rate of change, we'll shorthand it of a function. Well, the steps of doing this is find the average change of the function for the given interval, or you might also hear it as find the slope between these 2 points, right? Either or, they both mean the same thing. I don't know why it's ordered like this, like it's steps on how to do it. Not exactly. I think it's just different ways to say this. And so if we're ever given something like this, I can definitely find the slope between the 2 points that are crossed here and here. Simply just by looking at it, I can count how much I rise to how much I run. In this case, I rise 4 and also ran 4, right? And so that gives me a slope of rise over run of 4 over 4, which equals 1. So the average rate of change here, in this case, between those 2 points that are indicated right now, is just a slope of 1. Right? So let's go ahead and practice using this formula for a few examples functions on the given intervals. Right? So basically, we're just going to use the average rate of change formula or the slope formula that we saw mentioned earlier. Right? So I'm just going to quickly rewrite that formula for us. Right? The average rate of change formula is indicated by y2 minus y1 over x2 minus x1. Right? So we actually have some of the components of this formula already indicated by um, this interval right here. Right? This is going to be our x sub 1 and x sub 2. Right? So the only values that we're missing for this is our y2 and y1. So we're going to take some time to find that basically. So if you want to work through it and just skip to when I finally finish it, feel free to do so. But what you're going to do now is take the first x sub 1 value and plug it back into the original function to figure out what your x sub, or sorry, y sub 2 is, right? So if I take that time and plug it in, I should have f of negative 2, meaning I'm plugging negative 2 into all the x's that I see, and then we'll simplify and see what our result is. All right, so there is my equation there, and if I simplify, that's a negative and times a negative 2 cubed, which ends up being a negative 8 minus 6. And then if I simplify this all the way, you can see that this will become a positive 8 minus 6. So positive 8 minus 6 is positive 2. And so what we just found is our y sub 1, right? We plugged in x sub 1, we should have gotten y sub 1 back. And now we'll repeat the same part or same process again to find our y sub 2 by plugging in x sub 2, right? So we're going to take a moment now to plug this in. So let's see. Let's find my pencil tool. Let's put this down here actually. All right, so we're plugging in f of negative 1. So that's a negative times a negative 1 cubed plus 3 times a negative 1. Right, so if I simplify it, I think, let's do some mental math here. Maybe you could do it together with me. I know I end up being a positive 1 overall, right? Minus 3, which ends up being a result of negative 2. So there's my y sub 2. So I found every component that I need to go ahead and plug into our formula now. So I'm going to take a moment to do that, and we'll pick a different color to plug in with. Let's say green. So I should have negative 2 minus 2 all over a negative 1 minus a negative 2, right? All I did And this step right here is just take each respective x sub 1, x sub 2, y sub 1, y sub 2, and just plug it into this formula right here. That's all I did, right? And now we're just going to simplify this expression here. This leaves me with negative 4 all over a negative 1 plus 2, right? Those two negatives in the middle there will become positive, and my final result is just a negative 4 overall. So there's my average rate of change, right? And our slope. Now we got to do it again for this particular problem, right? So if you're already good with this and you're like, I get it, you can skip through the video to a part that you actually need. But we're going to go through it anyways in case you need this practice. So let's see here. So again, I already have my x sub 1, x sub 2 indicated by this interval here. And now I'm going to take some time and plug that into my equation that they provided. So let's find what our y sub 1 is first by plugging in x sub 1. So I'm plugging 1 first into the equation. So I have 1 plus 1 all over 1 plus 6, which gives me 2 over 7. So there is my y sub 1. Now let's plug in the other end of our interval, 4. So f of 4 is equals to 4 plus 1 all over 4 plus 6, which is equals to 5 over 10. And that simplifies to be 1 half. So that's our y sub 2. And now I'm going to take the time to plug that into our average rate of change formula. I'm going to just start saying slope formula. There's way too many words to say that, but you'll probably see that on the AP test or something. Okay. Let's see. So I kind of remember the formula already. Y2 minus y1. So 1 half minus 2 sevenths all over 4 minus 1, right? The only added difficulty of this problem is that we're dealing with fractions, right? So this is some good review to combine fractions in case you forgot. So the hardest part, or hard part, is the numerator portion here, right? So we can't combine those right now unless they have the same denominators, right? So as long as I multiply them by a common denominator, they should be able to combine like terms because then they'll be the same. So basically, I'm going to take these fractions here and multiply them by each of their respective denominators. So I'll take this one and multiply by 7 over 7, and the second one by 2 over 2, right? And so that ends up changing the numerator to be, well, 7 over 14, right? 7 times 1, 7 times 2, right? Minus 4 over 14, right? Now that my denominators are the same, I can combine like terms. Well, just the numerator really. So 7 minus 4 gives me 3 over 14, all over a positive 3. Now, we cannot leave our expression like this, and so the way we finish this up is by, well, I like to do it by calling it keep it, change it, flip it. And so if I do that, I keep the numerator as is, so 3 over 14 will stay. Change the operation, that's indicated by this fraction sign that I'm pointing at now, right? That's the division. So divided by, now change to multiplication. So we kept, or we keep, then we change the operation, and then we flip what's currently in the denominator. And so flipping it just means I want the reciprocal of it. So right now, this is technically just 3, which is technically 3 over 1. So if I flip it, 1 over 3, right? That's the reciprocal. So if I multiply straight across, I get 3 over, what is that, mental math? 14 times 3, what is that, 42, I believe, right? 28, yeah, 42. And I believe I simplify that a little bit further. I think even though it doesn't look like it, it should be reducible by 3 in both numerator and denominator, leaving me 1 over 14. And so there's my average rate of change there. And we are done with numbers 1 and 2. Now let's move on to parts or number 3 and 4, right? Given the graph of g of x, find the average rate of change of g of x over the interval -1 to 3. Now really there shouldn't be really curly braces here. It should really be a bracket to indicate the end of this interval. So just one small correction. And well, let's see. The intervals that they're indicating in this case is from, well, -1 all the way to 3, which is indicated by the point right here as well. They already gave us that point, which is nice. And You could use the average average rate of change formula here, the slope formula, right? You can like say, oh yeah, x1 is well this, and x2 is that, and then find the output values for those respective spots by looking at the graph. That's totally fine, right? The y1 will end up being is equals to 0, right? That's the y value at that point. And then y2 will be the y value indicated here of 4. And you can go through the whole entire process of doing the slope formula if you'd like. I'm not going to do that. I can visibly see this graph, and so instead of doing the formula, I'm just going to, I guess, visibly just do it by doing rise over run like you've done in the past when you first learned this. So again, I rise 1, 2, 3, 4, run 1, 2, 3, 4. So the average rate of change, the slope, is just, well, rise over run of 4 over 4, that's equals to 1, right? Hopefully that's simple enough. So if you can finesse it without doing the formula, feel free to do so. Now here's number 4. Let's see. It says let f be the piecewise function defined below. Find the average rate of change of f over the intervals of -2 and 3, right? I'm already going to just label those, and we're going to take some time and plug this in to see what our y1, y2 are, right? But since it's a piecewise function, we can only plug it into specific domains that are allowed, which are indicated on the right-hand side here by these inequalities. All right, so if I want to find our y2, or sorry, y1, I need to plug this -2 into the right spot. So following what inequality is allowed here, right, -2, well, that's the only one, well, that's the number that's allowed here because, well, -2 is less than or equals to 1, right? If I plug it in there, like that's a logical statement. So that means I will get to plug it into this equation here of this piecewise function, right? So I will now say f of -2 is equals to 3 times -2 minus 2. Simplify that, that's -6 minus 2, which equals to -8. So there's my y1. And then now, looking at the x sub 2, the last part of our interval, right? I'm pretty sure positive 3, the only restriction of the domain that's allowed to be in is the second portion here, right? X is greater than 1. 3 is definitely greater than 1. So I'll be plugging it into this part of the piecewise function. So f of 3 is equals to 3 squared. Let's do some parentheses here. Plus 1. And if I simplify that, that is 9 plus 1, which is 10. All right, so I have found my y2. Now I'm just going to take that time and plug it in to our average rate of change formula. And I'm going to go a little bit faster now because I think we may have gotten it at this point. All right, so 10 minus a -8 all over 3 minus a -2. This ends up being a positive 18 all over a positive, what is that, 5? And I don't think I can simplify that any further. And so that's my final answer for this portion, right? That's my slope. Now let's move on to this next part, right? This is saying that the graph of the linear piecewise function g is shown in the picture below. Find the average rate of change of g over the intervals -3 to 9. So again, I am going to cheat. Now, of course, you can totally, I say cheat, not really cheat. You totally can just plug this in to the average rate of change formula. I'm not gonna do that. I see the points that they're looking at, right? At the beginning of our interval at -3, we are right here, right? I know that point. I can see it. And then when we're at the end of our interval at 9, that's all the way at the right here at the end. Boom. Just do rise over run for those 2 points, right? If you're given a graph, just do it that way personally, okay? All right, so let's see how much I rise. 1, 2, 3, 4, 5. So plus 5. And then I run 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So rise 5, run 12. That's a classic way to do this. 5 over 12, right? There is our slope. All Sorry, my I think my headset just died and I needed to plug it in. So I'm back. Sorry, there was a weird little cut there. But yeah, we should have finished problem number 5, and our slope is 5/12. All right. Now let's see. We have problem 6 and 7, and then we'll be done for today. Hopefully the notes is not too long. Um, let's see. So there's a series of questions actually for problem 6. We're asked to graph the piecewise function, right? This piecewise right here, right? Y equals 2x plus 3 and just 5. Right, so I'm gonna do that step first, and then we'll try to answer some of the other parts of this problem. All right, so I'm gonna indicate these two different pieces of our function with different colors, and then represent the graph that way. So the first part will be in the red, that has a slope of 3. So I'll start my y-intercept there, and then do a slope of 2 rise to red 1. And I think that's a good enough number of points to really represent this graph. Boom, and then boom. I think you should be able to see that, right? And then let's also just make sure that we are following the domain restrictions that are provided to us, right? That red portion only exists um, everywhere that it is less than or equals to 1. So anything below or less than 1 is allowed, and so we just need to indicate that. So I'm going to erase the portions that are really not in that domain restriction, right? So 1 technically is right there, so I'll just label that just so I can mentally see that, and then erase that. And then I'm going to change my pencil tool to be partial. So if you're using like a notability or something, I just change that, and I'm going to erase the portion I don't need. So everything after 1 here, I don't need it. I don't exist there for that part of this piece, right? This is perfect. And I should leave it as a filled in circle here. I don't know why I erased it. I should leave it as a filled in circle here because I am allowed to be at that location, right? So this is that part of the graph. And then now I need to graph the second portion, right? This blue one that I indicated here. And it's just a constant value of 5, right? It doesn't change, doesn't have a slope. So really, I like to start where it is, right? It's the y-intercept of 5 with no slope. And so remember, if it's just a value like that, it's just going to be a horizontal line drawn at that location. So let's take a moment to do that. So I'm going to go to where 5 is and put a blue dot, right? So I'll count up 1, 2, 3, 4, 5. There it is. And then I'll put a dot there for right now, just so I can know where to place this horizontal line. And we'll draw that horizontal line going through it. And then we're going to fix it, of course, right? This line that I drew, well, it still has a domain restriction. It only exists anywhere where it's greater than 1. So I'll make sure to erase the portions that are, well, less than 1, because I don't exist there. I'll do that now. So anything on the left side here, don't exist. I don't exist here. And then add 1 physically for this horizontal line. Um, I can't be a closed circle, but I can be indicated by an open circle, right? So technically, since it's a piecewise function, you don't really need to indicate this, but since I did two different colors, I wanted to. But essentially, since the red one, right, the prior one that we drew was already filled in, and this is a piecewise function, they behave together. Um, it's basically just a filled in circle. Maybe we're seeing this as one uniform color, let's just say black, you wouldn't see an open circle at all. But I just thought I'd show it to you because, well, um, they're in two different colors. Okay. Now let's move on to answering some of the prompts that are provided to us for this problem. Right, so it says when x is equals to 0, what is the value of y? So basically just go to where x is equals to 0, and then find the graph at that location and see where our y value is. So 0 is obviously at the origin, and I'm just going to move my pencil up and then find where the graph exists there. And it looks like it exists at 3, so when x is equal to 0, y is equals to 3. And then when is x equals to 4, what is the value of y? So I'll go to where 4 is, 0, 1, 2, 3, 4. Then go up and find where my graph is, and it seems like, well, it's hitting my blue line, which is a constant value of 5 for the y values. So when x is equal to 4, I get 5 in return. When x is equals to 1, what is the value of 5, right? Again, I know I drew it in two different colors, and there's an open circle, but we have a closed circle that overlaps it. That means it does exist for this piecewise function. So at 1, we exist exactly at 5. as well, right? Good deal there. Let's see, what else, what else? What is the domain and range of the function, right? And you can also see in grayed out that we want to write it in interval notation, right? That's the brackets and the parentheses, right? So domain is, well, the list of all input values or all the x values, right? So if I look at this graph, I'll kind of scroll down so my face isn't blocking it. Um, from left to right, if I was to, trace, let's just say I'm going to highlight so you can see it. I don't think there's any gaps at any point of my highlighting, right? As I kind of go through it here, I'm going to pick a bigger highlighting tool here, right? There's no gaps, right? From left to right, even here, it's a filled in circle. So um, it seems like I'm going left and right forever with zero gaps in the middle. So that indicates that my domain will should be everything. And the way we indicate that in math is with, well, two ways, right? I'd say this is the fancy way, right? We say all real numbers. But since they're specifying that we write it in interval notation, then what we write that for this is what we say negative infinity, comma, positive infinity. So we're going to include every single number in between the infinities and everything beyond it, right? So that's all real numbers. Now, let's go ahead and do, what is it? Well, I just did the domain, right? This is my domain. Let me actually add some more notation here, right, to indicate we did the domain. Now let's find the range, right? Range, I think from bottom up, right? Domain left to right. So range, let's start from the bottom and go all the way up and trace, right? As I start from the bottom, let's erase what I currently have highlighted, right? If I start from the bottom of my graph, well, I start here. And as I trace it going up, right, there are no gaps as I go up this graph, right? Even though I'm not going up anymore here, it still counts, right? But right there, you can see that we kind of taper off. We've stopped going up, right? We are just at a constant value of 5. So the bottom of this graph, right, indicated by this arrow here, means I'm still going down forever, right? I can't fit that on my graph, so we indicate it by that arrow. So we'll say our range starts from negative infinity, right? It was going down forever, and then we kept going up until it tapered off, right? We only went up so much until we hit 5. And that was the end of our range. So we'll say negative infinity to 5 is the range. Now, there is a slight issue with what I just wrote, right? Um, the parentheses are all fine for the most part, except for this one at the end here, right? Be mindful that the parentheses indicates that, well, I can never really reach that value, right? So we do have 5. So I should change this really, right? We should change it to be a bracket to indicate that value does exist in our interval, right? I do have 5 existing on my graph for my outputs, right? For my range. So hopefully that's helpful for that problem. And then we have one more to go through and we'll be done for today's notes, right? I've been recording for 20 minutes already. Well, actually more. It's just this part because I messed up the other one. That's a long time. Dang, I talk a lot. Anyways, let's see. So this piecewise function consisted of 3 different equations. So I'm going to take a brief moment and graph all 3. The 3 colors I'm going to choose, well, is red, green. Oops, that's not green. Red, green, and then blue. So the red one should have a y-intercept of 2 with a slope of negative 2 over 3. So down 2 over 3, down 2 over 3. And I'll repeat it for the other direction. Up 2 over 3. And that looks good enough. Connect my dots. And again, I like to graph the whole thing and then adjust it as I go. So in this case, we do have a domain restriction of x is less than 0. So this red portion of the graph should only be drawn where x is less than 0. So I'm going to erase everything on the right-hand side of the origin. And right at 0, technically, I am strictly less than 0, so I don't actually exist there. I'll draw an open circle to indicate that. Okay. Now, if you want to be really particular about it, I would erase this whole thing and draw like an actual circle. Okay, but I usually draw the other way because I'm lazy. Now let's do the green portion. This one has a y-intercept of negative 2. and a slope of 1. So pretty easy to sketch. This one I'm going to save some time, right? I can already kind of see that the interval in which this portion exists is at 0 and 7, right? I can be equals to 0, but strictly less than 7. So I'm just going to connect it right now if notability doesn't keep clipping it down there, right? I'm just going to go ahead and adjust it on the fly this time instead of erasing it. So there's my portion here, and I will make sure to draw an open circle. Oops, actually, aren't we past 7? So maybe I will erase a little bit actually. Let's go back to right there, and now draw an open circle at 7. So this is the second part of our piecewise function. And now we'll do the last part, right? Which is pretty simple, just a constant value of -6 with the colored blue. So let me count down. 3, 4, 5, 6. And then I only exist from 7 to 10. So it'll look like this. Slightly off due to the notability clipping it, but maybe I'll adjust it. Boom. And I don't know why I drew these arrows. I do not need to draw those arrows. Oh, that is not good. Right? It actually just stops at those spots. That's it. Then I will draw some dotted to really indicate that I include the ends of those intervals. So there's our piecewise function, and now I'm going to go ahead and graph this, or not graph this, answer the portions that they ask us. And of course, you could plug these values into here, here, and here, and then just, figure out that way if that's easier for you. But for me, I'm just going to use the graph that I drew. I've spent so much time on it, might as well just use it to my advantage, right? So when x equals a -3, it seems like, well, I exist right there, right? So that has a y value of 1, 2, 3, 4. What is that? Yep, 4. And then the green one at x equals 2 probably, right? I am right here, and it's kind of perfect, right? It's already in, like at 2, my graph definitely just crosses it right there. So that has a y value of 0. Then x equals 8, I'm pretty sure will be in our blue portion of our graph. And it seems like, well, since it's constant, it has to have the value of -6. So uh, there's the answers to that. And now we'll answer part D. And this one will be slightly bit more trickier compared to the domain arranged before, but I'm sure we can do it, right? So let's first do domain, right? D colon. Um, the domain in this case, again, let's go from left to right and really just trace it. That's how I like to do it when you're first learning it or seeing it again. So that way you can get to see how I think about it. Right, so from left to right, no gaps. Now, even though I just stopped right here, right, and there's a gap indicated by that red circle, um, I don't really have a gap, right? I do exist at x equals 0, right? You just have to jump down a little bit. So from left to right, if I was like to imagine a little guy walking, right? Um, I'm not gonna draw completely, but left to right, right? Even though there's a hole here and I fall through it, there's something to catch me, right? So there's really no gap at all per se, right? So domain here is still pretty solid from left to right. And I'll keep going, right? Left to right, left to right, left to right. Right? I get to here, and again, I fall again, right? There's technically a gap here, but again, I technically have something to catch me. So my domain, there's really no gaps at all, right? So really, from left, right, the furthest left, technically, is, well, going on forever, right? There's an arrow here indicated on the left-hand side. So I still have a negative infinity for my left-hand side. And the end of the interval here, all the way towards the right, again, there was no gaps. So at all the way to the right is indicated by this blue portion, right? And it does stop there right at 10, right? I have negative infinity to 10 as my domain. And then as far as range goes, this one's a little bit more tricky, I feel like, because the way I like to think of it is I like to flip my head maybe, or mentally I do, and go from bottom up and see if there's any gaps. So technically I'm taking my little guy here. Let me go ahead and just change the way he's orientated, right? Kind of like this. And again, when I think about range, I go about bottom up, right? So I go this way. So I have to start here. This is where I start to get to stand on something, right? So the range right here gets to start right at, what is that, -6, right? So I'll say -6. And let's see what happens. Well, there's clearly a gap, right? I would have to take my guy here and jump, right? There's really no way for me to go up in this sense, right? There's a gap for my range. So I don't exist here in terms of range, right? I don't exist any values here from -6 to 2. And I have to indicate that with my answer for the interval. So right now, the first portion I'm writing should only be -6, and I can close the bracket right now. And then we'll use this union symbol to indicate the next part of our interval, right? The next part where we actually can stand on. So if I take my guy now, move him up, right? I get to start existing again, right? I get to walk again on this portion right here, right? And so as I go up, 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 there's a hole here, and I fall this way, right? So the it doesn't really the physics here doesn't make any sense, but hopefully you get the idea. And so I get to keep going. And so even though there's a gap here, I get to fall into something that lets me keep going, right? So the range is pretty continuous at this point. So I'll say starting from the bottom of the green portion, which is at -2, I could go all the way up to infinity forever, right? It still goes up forever. So I'll say -2, close bracket, all the way to infinity. Now you might be wondering, well, why didn't you account for the other gap here? Right? And that's a valid question. Well, if you just change the way our game works and just fell the other way, right? Let's just say we change the orientation of this guy or person. Say we start here, right? Boom, 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 and then I technically have to jump here, right? This is the next part. I'm going like this, and I'm falling this way. Um, Technically, even when I try to get to here, I fall immediately, right? But something catches me, so the range still exists. And then it's kind of weird now, right? Technically, I still want to be here because I'm falling this way, and I just keep going anyways, right? I wouldn't keep walking this way. If that makes absolutely no sense with my drawing, I'm so sorry. If you already have a good idea of domain and range, great. But that's the way I kind of think of it. But that's it of our notes, at least for day one. So hopefully that's pretty simple enough. And yeah, that's the end of the video. Hopefully you're having a good day, and I'll see you in the next one in case you watch it. So bye. Have a good one.